All right, in this video, we're trying to find the standard form of the equation for the given circles. So let's look at example A. They want us to find the standard form for the equation of the circle that's drawn here in picture A. So let's talk about what the standard form is, first of all. The standard form is basically this form, and that form involves finding the h comma k center. So the center is given as h comma k, where h is the x-coordinate of the center of the circle, and k is the y-coordinate for the center of the circle. And then we have to find r. R is the radius of the circle. Of course, the x and y in the formula will remain x and y. They remain variables. So our whole goal is to try to figure out where's the center of the circle and what's the radius. How long, in other words, is the radius, the distance from the center to the edge of the circle. Well, we can figure all that out by using the distance formula primarily. So in example A, we can use the distance formula to determine the diameter of the circle, because it looks like the 2 points they're telling us that lie on the circle both fall on the diameter of the circle. In other words, they're the endpoints of the diameter. We can see that because essentially they have the exact same y-coordinate, right? So it looks like they're going right across the circle from one end to the other. All right, so if that's the case, then we should be able to use the distance formula to determine how long the diameter is. And then half of that distance is simply the radius. So let's start with that. So the distance formula, remember, is equal to the square root of the distance between the x values squared and the distance between the y values squared. All right, so the difference between the x values is essentially 5 minus 2, while the difference between the y values is essentially 2 minus 2. So that's nice, because then we can say that the y part cancels out. So we end up having 5 minus 2, which is just 3 squared, plus 0 squared. And that, of course, is just the square root of 3 squared, or the square root of 9, which, of course, is just 3. So the distance there is 3. Now that's the diameter actually, right? Because that's all the way across the circle. So if we want to know what the radius is, we just have to say it's 1/2 of 3, or 3/2, which is the same as 1.5. All right, from here what we want to do then is to go ahead and take the radius and use it as a way to establish where the center of the circle lies. Now we can see from the drawing that the center of the circle would lie on the same y-coordinate, right? And it should be 1.5 steps away from the left edge of the circle. So in other words, from this point on the x-axis, the x-coordinate is equal to 2 there, right? So the x-coordinate is equal to 2 for that point. If we add to it 3/2, then we should end up with the location of the x-coordinate for the center of the circle. Now, of course, the y-coordinate will be the same. It'll just be 2. And the reason why is because, of course, that little line there that we have drawn on the diameter, the center lies along that line. Okay, so 2 plus 3/2, we can write that as 2 over 1 plus 3/2, which is the same as saying 4/2 plus 3/2, right? Because 4/2 is the same as 2. 4 divided by 2 is equal to 2. And that, of course, will give you 7/2 as your x-coordinate. So that means that your x-coordinate for your center is 7/2, while the y-coordinate, remember, will be 2. So that's your h comma k center. So remember, the x-coordinate is referred to as h, while the y-coordinate is referred to as k. Okay, so you have your center and you have your radius. Let's put it together then into the standard form for the circle. Okay, so it'll end up giving us x minus the h part of our center, which is going to be 7/2 squared, plus y minus the k part of our center, which is 2 squared, and that'll be equal to r squared. R squared, of course, would be the square of 3/2. That'll give you 9/4 if you square both the top and the bottom of that fraction. And so that's the equation of that circle in standard form. All right, let's take a look at example B then. For example B, it's a little different. They tell us that the center is at 2, 3, and the circle is tangent to the y-axis. So tangent means it hits the y-axis exactly in one place, right? Exactly at one point, and then it sort of never touches it again, right? So sort of right up against the y-axis, but only touching the y-axis in one single spot. So let's kind of take that into consideration after we draw the center. So let's put the center on our drawing first to get a visual representation. The center is at 2, 3, so we're going to say that would be right about there, right? And the fact that it's tangent to the y-axis means that the outer edge of the circle kind of hits the y-axis, right? And then sort of the circle spins around from there. So we're going to say that that's kind of what our drawing looks like, and that would mean probably that it's hitting at what? The point here, which looks to be the point 0, 3, right? In other words, 0 on the x-axis, but 3 on the y-axis. So it looks like we maybe have 2 points then. And with that second point of 0, 3, we should be able to figure out the radius for the circle. We can certainly tell what? The center. The center is 2, 3. They gave us that. So we have the h and k. All we need to get is r. So to get r, we just need the distance formula, so we need an additional point. That additional point is 0, 3, because that's how it would be tangent to the y-axis. It would have to hit that and then just kind of turn away from it after that. So that means our distance formula can be used. So again, it's the square root of the difference between the x parts plus the difference between the y parts, right? So look, taking the 2 points, if we use the center as our first point and the other point as our second point, we can go ahead and say that the difference between the x values are going to be 0 minus 2, and the difference between our y values will be 3 minus 3. Now, at that point, again, same thing that happened before, we end up losing the y part, and we end up with 0 minus 2, or negative 2 quantities squared, plus 0 squared. That will end up giving you 4 after you square negative 2, right? And then plus 0 is just 4. And you take the square root of 4, of course, you get 2. So it's telling us that the distance from there to the y-axis, of course, is 2. Now, we could see that from the drawing, obviously, right? It's very easy to see that we went out 2, right? 1, 2 to get to where the center was located. So, of course, it had to be a distance of 2 to the y-axis. The distance formula is just to confirm that. Okay, so once we know that, we have the size of the radius, because that's literally what? The length of the line from the center to the outer edge of the circle. Okay, so let's plug it into our standard form. So we'll end up having x minus the h part of our center. That means the x part of the center, which we said was 2. That'll be squared, plus y minus the k part of our center. So remember that our circle up here is h comma k for the center. So the k, of course, will be 3. That'll be squared. And that'll be equal to the radius, which we just decided was 2. So we'll square that 2 to get 4. So the final answer is x minus 2 squared plus y minus 3 squared is equal to 4. And that's the standard form for equation B.